All right, so I got you started a little bit with the solution. Hopefully, you've figured out your own solution and it works and you're proud of it. What I'm gonna do here is just show you how I did it. The first thing was I wanted to clear the screen, so I had to Google for this, and I found this rather crazy cryptic string. But it is apparently the way to send the message to clear the screen. So in my while loop, the first thing I want to do is to clear the screen. So when I print this to the terminal, it'll clear it. And then the next thing I want to do is print the current state of the board, which is what we're doing here. And then I need to determine if there is an error. And if there is a winner, and if there is, I need to print those and deal with it. So if there's an error, I just need to print the error. If there's a winner, I need to state that winner and then break, because we're done and we just need to exit the program. So that works rather well. I'm just going to open up solution one and copy those couple lines into our program. And as we're going through this, we'll see how to modify this. And I'll just put maybe a break here. Whoops. I'm just going to put a break here, just so that just so I can run it. And if there's a winner, let's see. And so I'm going to remove this. We're going to be finding the winner in a different place. Let me just make sure it still works. Yep, it printed one board. There was no error, so it was nothing to print. There was no winner, so there was nothing to print. And then we did a break. And then this is what I decided to do. That there would be a function for getting a move. And I'm going to pass in the existing state, and then I'm going to override the existing state with whatever comes back from get move. And so, what does that function look like? I'm just going to go over here, and it's a rather complicated function, so I'm just going to copy it. And then we can, whoops, that is not at all what I intended to do. Working with a new mouse here. So it's a little difficult for me. Oh boy. And this is why I really prefer using, I usually work with VI is my editor of choice, but that's fine. Okay, I'm going to paste this in here. This is my get move, and as you see, it takes a state which is of the type state, and it's going to return something that's of the type state. And what I'm doing here is I'm saying I'm going to copy player out, because I'm going to use this over and over again a few times. So I want to put it into a variable, and I need to figure out what is the cell that they want to take. And I'm going to use the input function, and that function wants a string that is the prompt to show the user, and it's going to return a string. So it's going to say player, whatever is the player currently, player X, what is your move? And this is really important feedback so that we always know exactly which player is going. And this is what is your move, and we have Q to quit. And I just immediately determine if the cell is equal to Q for quit. I'm going to return. I'm going to leave this function right away, and I'm going to replace the quit value of the state variable with the value true. And then that's going to trigger an action up here in the while loop to determine if I want to quit the game or not. I'm going to look at that. So if it's Q, then I'm out of here. And then the next thing I look is to see, is that cell, is it a digit? And so there's a function in the string class called isDigit, which will tell you if the string can be converted to 0 through 9. So if it is a digit and the integer value of that cell, because remember cell is still a string, if we convert that to an integer and it's in the range of 1 to 10, then if both of these things were true, then it would be a valid cell. And then we're negating it all by saying if not. So if it's not true that this thing is a digit and that this thing, when converted to an integer, is in this valid range, we're going to replace the error of our state with this error message, letting the user know that that cell value that they gave us is invalid, and telling them exactly what to give us. The values 1 to 9. And so again, we immediately leave the function if that's what we get. So if we get to this point, our cell is a digit and it is in a valid range, so we can convert it to the number here, the cell number. And then I'm going to mutate the board. Well, first, I'm sorry, I need to check if the board at that location is or is not occupied. And so this is exactly out of the first version that we did. This is how we check that. And then if it's true that that cell is already taken, again, I'm going to leave this function returning the state where I'm replacing the error message with this, that the cell is already taken. So it'll be up to the calling code to deal with the error. So this really gets at how you want to write code. How do you return from a function the idea of an error? What I'm returning from this function is always a state. So a state goes in, a state comes out, and it's up to my calling code to decide what to do when there are errors. You might have decided to write a function that returns, maybe it throws an exception to state that there's an error, but then of course you have to deal with those exceptions, and again, I like to avoid exceptions as much as possible. So I'm basically going to stick into this slot that there's going to be this error, and it's going to be the other code's responsibility to deal with that. Those are the errors. Basically what I have done is all the defensive programming. So I see if we want to quit. I see if this is if we want to quit, we're just done. If this thing is not a valid number, then we're out of here. If this thing isn't a valid number in the range, but the cell's already taken, then we're out of here. So if I got to this place, I can now change the board. So I'm going to copy the board out of the state. I'm going to change the board in this way, which is what we did in the previous version, and then I'm going to return the new state, and again using the underscore replace method, where I'm now saying that the board is equal to the new value of board. I'm going to swap the player from X to O or O to X. I'm going to say that the winner is equal to finding the winner of this board, this new board that we've changed, and I'm going to say that draw. So the draw needs to be true or false. I'm going to say it's a draw if it's true that there are no more dots in the board. So all the slots are filled, there are no dots, and that means that we've got a draw. And if we've gotten to this point in the code, there are no errors. So I'm going to make sure that the error value is none. I want to make sure that there's not some leftover error from a previous version. And so at this point, we're looking pretty good. We've got back this, so we've checked if there are errors, and we're going to print them. If there's a winner, we're done. And then we're going to get the move. So what's the next thing I do here? I need to check about quitting and draw. And so instead of break here, I'm going to paste in this code. So first, I need to see if there are errors or winners. If there's a winner, we don't need to get the next move. So we're done. So if we get to this point, we get the state, a new state. If the state is that we're quitting, we want to insult the loser, and we're done. We break. If there's a draw, then we'll print this message. We'll call it a draw, and then we break. So that is pretty much the game, the way that I coded it. I don't think there's anything else to run here. I think if we run it, we can see if it works. So I'm going to put X and 2, and then I'm going to take 5, and then he's going to go to 3, and then I'm going to take 9, and X is 1. That seems to work. We can then try to fill it all up in such a way that no one wins. And then we're going to take 7, and then X is going to take, let's say, 8. And then O is going to take 9, and then that's going to leave X to take 6, and now we get to a draw. And so I have determined that the program looks to be pretty good. And again, the problem here is that we can't really write an interactive test for this. It'd be kind of difficult. I don't really feel like getting into that, but we can still use our unit tests. So we basically have the same unit tests as before. We could still have run pytest xv on unit, and it's going to see that, you know, those same functions that we coded before using the same tests, they work. They're great. So when you know, even though this is an interactive program, there's still things that we can put into functions, and then we can write unit tests for those. So, you know, we have these functions for formatting the board and for finding the winner. Just as much as possible when you're writing code, try to break the problems down into the smallest possible units, write those as functions, and then write your unit tests to verify those functions work. And so that is my interactive version of tic-tac-toe. I hope that maybe you did it in a different way. Be happy if you would share that with me. We're going to follow this up with a short discussion of using typed dictionaries instead of name tuples.